In this video, we are going to focus on multiplying and dividing rational expressions. So for multiplying and dividing rational expressions, just like how we multiply the fractions, we follow the same kind of procedure. For multiplying rational expressions, factor all numerators and denominators completely. That is step number 1. Then divide numerator and denominators by common factors, which means cancel out any common factors between numerators and denominators. And then lastly, multiply the remaining factors in numerators and multiply the remaining factors in denominators. It's also okay to leave your final answer in the factored form. That way, it's okay to leave it in the factored form, right? Just the way we multiply fractions. Remember, we do not need to find common denominator when we are multiplying or dividing. Very important. We only need common denominator when we are adding or subtracting fractions or rational expressions. When we are multiplying or dividing, no need to find the common denominator. So let's look at a couple of examples of multiplying rational expressions. So first step is go ahead and factor every single numerator and every single denominator. X minus 3 cannot be factored anymore. X plus 5 cannot be factored anymore. X plus 5, 2x plus 10, we can pull out a 2. There's a GCF. And x squared minus 9 is difference of squares. So here's all the expressions in the factored forms. Let's cancel out the common factors between numerators and denominators. And now we're just left with 2 in the numerator and x plus 3 in the denominator. And that's our final answer. Let's check out example number 2. Let's factor every single expression. I see x squared minus 1 is a difference of squares, which will be x plus 1 times x minus 1 in the factored form. X squared plus 4 would be x plus 2, x minus 2 in the factored form. X plus 2, x minus 2. X squared minus 5x plus 6 can be factored into x minus 3, x minus 2. And x squared minus 2, x minus 3 can be factored into x minus 3, x plus 1. Okay. Now once all expressions are factored, we're going to cancel the common factors between numerator and denominator. Your factoring skills must be very solid in order to proceed with this chapter. Otherwise, you will struggle if you don't recall your factoring skills. X plus 1 and x plus 1 can be cancelled between numerator and denominator. X minus 3 and x minus 3 is gone. X minus 2 and x minus 2 is gone. And we are just left with x minus 1 over x plus 2. And that's our final answer. All right, example number 3, 4x plus 8 over 14x minus 7x squared times 3x squared minus 5x minus 2 over 9x squared minus 1. Let's go ahead and factor every single expression. Looks like 4x plus 8, I can pull out a GCF. 14x minus 7x squared. 7x is the GCF, which would be 2 minus x, I believe. Yeah, 2 minus x. And 3x squared minus 5x minus 2. Two numbers multiply to give you negative 6, add up to give you negative 5, are negative 6 and 1, and we would divide them with a 3x and 3x. So the 3x plus 1, as well as in the simplified form x minus 2. 9x squared minus 1 is difference of squares, so 3x plus 1 times 3x minus 1 is what that factors into. Now if you look carefully, the x minus 2 and 2 minus x, they are opposite of each other. So I'm going to pull out a negative from one of them and write it. So I'm going to pull out a negative from 2 minus x and write it as x minus 2. And then we have 3x plus 1, x minus 2, 3x plus 1, 3x minus 1. Let's cancel out all the common factors between numerators and denominators. 3x plus 1 and 3x plus 1 is gone. X minus 2 and x minus 2 is gone. And all I'm left with is 4 times x plus 2 in the numerator and 7x, there's a negative in the front, times 3x minus 1 in the denominator. And that's it. Cannot be simplified anymore. If you prefer, you can distribute the 4 into the parentheses, or just leave it like that. And same thing with the denominator, we can distribute the 7x in there. So if you really want to change your answer, you can write it as 4x plus 8 divided by 21x squared minus 7x. Okay, let's look at another example of multiplying rational expressions. Here is example number 4. Y square minus 11y plus 18. Two numbers multiply to give you positive 18, add up to give you negative 11 are negative 9 and negative 2. Y square minus 5y minus 36, y minus 9, y plus 4. And y plus 4 is already factored, cannot be factored anymore. This is a 4. All right. Let's cancel all the common factors, y plus 4 and y plus 4, y minus 9 and y minus 9. In the numerator, I'm only left with y minus 9. In the denominator, I'm only left with y. That's all. Do not cancel the y and y, because in the numerator, you have a binomial, y minus 2. So the y in the numerator is not in the factored form. Right, here's next example. Let's go ahead and factor it out. Difference of squares, a plus b, a minus b. And in the denominator, I can pull out a 10a, a minus b. 5 comes out, 2a plus b is what I'm left with. And then 2a squared plus 3ab plus b squared. This is a trinomial in 2 variables. It's a trinomial in A, quadratic trinomial in A, going from left to right, and it's a quadratic trinomial in B, going from right to left. So to factor it, you can, for a minute, think about how would you factor an expression like this. Well, that would be 2a plus 1 and then a plus 1, because that would give you 2a squared plus 2a plus a plus 1. Now, because we also have a b square here and a b here, so we would multiply, we would add a b and a b, so that when we open up this, FOIL these, we get our original expression back. So it's going to be 2a plus b times a plus b. Let's cancel 2a plus b, 2a plus b, a minus b, a minus b, a plus b, and a plus b. And between 5 and 10, we can divide both of them with a 5. Numerator, everything cancels. We want to have a 1 for the placeholder. Do not forget that. It's very, very important, because everything canceled in the numerator. We want to keep 1 as a placeholder. And in the denominator, I'm just left with 2a. So that's it. That's the final answer for this problem. Let's look at one more example of multiplying rational functions. So x squared plus 3x over, these are the try me problems. Go ahead, pause the video, try these problems, come back and check your answers with me. So you are supposed to start by factoring every single expression and then cancel out the common factors between numerators and denominators. And then from there, just leave your final answer as whatever you're left in the numerator and whatever you're left in the denominator So 2x squared plus 11x minus 6, that is going to be 3 minus n and n minus 3 are opposite of each other. So I'm going to pull out a negative sign from 3 minus n and write it as n minus 3. And now cancel the common factors, n minus 3, n minus 3, and plus 2, and plus 2. Again, everything in the numerator canceled. We do want to have our placeholder, which is 1 in the numerator. You can leave the negative in the middle. Same thing. Okay, that would be all. This is all for multiplying rational expressions. I'll see you in the next video with dividing rational expressions.